morning and good afternoon, everyone. I'd like to thank everyone for attending today's webinar. Today we have an introduction to performance and load testing. This is in a series, the second in a series of guest speakers. We have today is Andy Hawks, who is the founder of Load Performance Testing. Andy, take it to you.
Thanks, Reg. Good to be here. So like Reg was saying, I'm Andy Hawks. I'm the founder of LoadstoPerformance. We make load testing software and also provide professional load testing services, which includes like front-end and back-end performance tuning and also training sometimes. We've been a Polarian partner since June of this year, really excited about that, and we're already working on an upcoming integration with Polarian QA, which will be really cool. We'll give you a sneak preview of that a little later. So this is an introduction to load testing, so we'll talk a little bit about what load testing is, talk about the distinction between performance and scalability. Those are two terms that are often used interchangeably, but they're actually quite a bit different. Talk about different types of load testing, different motivations, why you might run load tests. We can also talk a little bit about where load testing fits in the application lifecycle, regardless of what process you're using, when it makes sense to do it, when you can get away with not doing it, that kind of thing. We'll have a little live demo of Loadster, and also we'll talk about the integration that I mentioned with Polarian QA. So feel free to ask questions at any time. I think the moderators are taking questions, and then we'll break for questions every few minutes or so. So yeah, anything that's on your mind, just speak up. What is load testing? Many of you probably already know this, but simply stated, it's a way to test how your application behaves under load, right? Under load meaning typically when lots of users or lots of clients are hitting it at once. It usually involves three main things. A production-like environment, if possible, because you'll get more meaningful results that way, obviously. You need a functional application. This doesn't mean it has to be like fully functionally tested, but it at least has to, like the main flows and whatever is in scope for load testing obviously needs to be working. And also some kind of tools to generate the load, because it's not practical to have people generating the load manually. So some kind of tools are required. And not only generate the load, but also measure response times. So what kind of apps does it make sense for? Pretty much any app where there's like multiple users for a single instance of the application, and where you have a significant number of users, more than a small handful probably of total users. So obviously that would include web applications, it would include web services, also traditional client-server apps. You know, like even if they're not using HTTP as the protocol, sometimes you can have apps that are client-server where there's lots of different clients connecting to a single instance of the server side. And then even static websites too, because those have lots of users, obviously. So load testing is important because speed matters. People's attention spans nowadays are probably shorter than they've ever been. Akamai and Gomez did a couple of studies and surveys, and they found that at least as far as consumers are concerned, they say 40% of consumers will abandon a page if it takes more than 3 seconds to load. So that's not much time, and 40% is huge, right? If you're doing like e-commerce or whatever, obviously that's a 40% knock on your conversion rate right there, or whatever it is that you're doing. And they also found that 79% of dissatisfied customers will just avoid that site in the future. Also, 27% said, well, they would just immediately jump to a competitor's site instead. So, yeah, obviously performance and responsiveness is hugely important from a consumer perspective. Amazon also did internal studies. They're always tweaking and optimizing things, and that's kind of what they're famous for. And they found that for them, a 100 millisecond, that's just a tenth of a second delay is a 1% loss in total revenue for them. So that's huge. Like a tenth of a second is barely perceptible, but that shows that to end users in aggregate, it's really a big difference. So a few cautionary tales also about scalability in particular. During the Super Bowl earlier this year, that's a big football game here in the U.S., if anyone doesn't know. Coca-Cola and Acura both ran expensive commercials. You know, they paid millions of dollars to create the commercials, probably, to produce them, and then also millions of dollars for the airtime, only to see their websites crash when people tried to go check out the website. So obviously a huge waste there. Target's website went down a few times last year under heavy load from popular sales that they were doing. It went down once and then again like 6 weeks later. Another story, the UK launched this petition site, I think it was last year, called DirectGov, and it crashed shortly after release because they didn't really plan for the load. They had over 1,000 unique visits per minute as people tried to sign and fill out these petitions for legalize marijuana or leave the EU or whatever it was. So yeah, they crashed, and all of these are things that could have been prevented if they planned better and had proper load testing ahead of time. It's also interesting because we're all nerds here probably, and we talk about this stuff, but it's interesting because all these crashes were covered very prominently in the mainstream media. New York Times wrote whole articles about it, which were featured prominently. And The Guardian showed articles, as well as countless local and smaller news outlets, not to mention all the blogs and stuff. So it's kind of a big deal when something crashes like this, especially if it's a big consumer-facing thing. And there's an expectation that obviously that things are more reliable than that. That doesn't mean that we're off the hook, though, for internal enterprise applications. Yeah, you might have a captive audience to a certain extent, so you don't have to worry as much about conversion rates and about just losing people. But still, time and talent of employees is a hugely important resource for any company, and slow tools waste that. I mean, the times in my career when I've been at really large companies, that was always one of my little gripes, I guess, was some of the internal tools and things. Either they didn't always perform well, or they just took too long to do stuff. Or sometimes they were unreliable. So obviously it's a continuing battle, but it's something that load testing, I think, in a lot of cases can definitely help with. To talk a little bit about the relationship between performance and scalability. So I mentioned before that sometimes we use these terms interchangeably, and performance especially is a little bit of a broad term. It can mean a lot of different things. But for at least for this webinar, I'm going to define it as baseline performance, meaning how fast your application responds under minimal load and ideal conditions. So that, only a couple people hitting the application, maybe you're the only one, there's no network problems or anything. This is your baseline performance. That's as good as it gets for an application. And most modern apps have decent baseline performance. Not all of them, but most of them at least have pretty fast responsive pages under minimal load. Scalability, on the other hand, is how well your application is able to maintain that performance as the load increases. So as more and more users are trying to access it simultaneously, at some point you're going to see a degradation in response time. The graph that I've drawn here obviously is a very crude graph that just shows the exponential nature. A lot of the time in real life what we'll see is the application will be really responsive up to a certain point. So it'll do fine with one user, it'll do fine with 20 users, 50 users, 100 users, sometimes 200 users. But it always hits a point where suddenly it hockey sticks and the graph will shoot upwards and you'll see response times go through the roof. And that basically means you've hit a performance bottleneck, a scalability bottleneck, I should say, of some kind. The trick with it is, though, that, why is load testing important to establish that? Well, performance under heavy load is just really hard to predict, even for seasoned experts. I've architected different systems before, and usually as I'm designing the system and building it, I have a hunch that, this is probably going to be CPU bound, or, it's doing a lot of disk access, it's probably going to be I/O bound or something. You have a general idea about that, but really it's very hard to predict for sure what the bottleneck's going to be, and it's even harder to predict at what point the bottleneck's going to be hit. How many concurrent users until we hit this bottleneck and the response times get bad. A lot of the time applications will seem fast and responsive during functional testing, but that's because only a few people are hitting them. And so if you're not doing some kind of load testing as part of your process, a lot of the time you risk when it hits real-world traffic and real users start hitting it, you'll see very different results in terms of performance and responsiveness than what you saw all throughout functional testing and user acceptance testing and all that. So bottom line is, simulating real user load is pretty much the only way and the best way to know ahead of time how your application is going to scale in production. Here's just some of the bottlenecks that I've personally come across. There's other ones out there for sure, depending on what kind of frameworks and what kind of applications you're building. But these are the ones that I frequently have come across. And you really just don't know what it's going to be ahead of time. Sometimes it could be an issue that you can just tune for. You can adjust maybe you're running Java and you can adjust the JVM parameters a little bit. Sometimes it's a coding issue. You've got to go back and change the code, or sometimes you find that you need to add a caching layer. It's just really hard to tell until you test it and then measure what the bottleneck is. So just to recap then, benefits of load testing. Number one is it helps you prepare ahead of time for production traffic. You know that your application can scale effectively before release, so it greatly minimizes the risk of like an expensive failure in production. Also, it helps you with ongoing work to optimize your system. Even if you have an application already deployed in production, you can do load testing and then hand in hand with some performance tuning to help optimize the system and reduce your costs, all your hosting and infrastructure costs. Also, it can help during development between iterations. It can help you measure changes in scalability to make sure it doesn't degrade. This is especially useful if you're doing, maybe you're doing some database work, like adding indexes or something, or maybe you're adding a caching layer to your application. So it's really good to measure before and after. You can run the same load test before and after and then find out exactly what the impact was of that change. There have been times when I've made a change and I thought it would make a big difference and it didn't, and then there's other times when I've made a change and it's had a huge impact. So it's a really good way to know what you're doing, so you're not just spinning your wheels and making changes somewhat blindly. And then just overall load testing as part of a process helps to deliver faster response times, improve your overall conversion rate, whatever those might be, and provide a better user experience. So any questions so far?
Andy, we do have a question here. I'll just paraphrase it. What if I don't have an exact copy of my production environment to use for load testing, and can I test on a different environment?
Yeah, good question. So, yeah, I mentioned before it's really important to, if possible, to have a replica of your production environment to run load tests on. That's the absolute best case. Some people also, like if you're releasing to a new environment and it's a new project, you can use the actual production environment before you flip the switch to go live. That's probably your next best choice. If you're forced because of cost or whatever to use like a smaller environment, you can do that, but you just have to be careful of what you try to extrapolate. So for example, let's say you're deploying your application on a single app server for testing purposes, but in production there's going to be 4 app servers. It's not at all safe to assume that it's going to scale 4 times as big in production, because there's always other bottlenecks such as database and stuff, which are typically there's a single database unless you're doing sharding or something like that. But yeah, that would be the big thing to watch out for, is just don't try to extrapolate too much based on the results in a smaller test environment. One thing you can do safely, though, if you have a smaller environment, is you can run your tests against a smaller load testing environment and then assume that's the worst case scenario, right? So let's say in production you're going to have a dedicated database plus 4 app servers, and you've managed to scrape together like a load test environment where you have a dedicated database plus 1 app server. You could certainly run all your validation load tests and say, well, okay, looks like it worked as sort of a worst case, and you can assume that production's probably going to at least be somewhat better than the test environment. So it's kind of a yes and a no answer. The best thing, of course, is to have the replica, but if not, then just be careful of what you try to assume. Anything else? Any other questions?
No, we can continue.
So let's talk about different types of load testing. I talked already about the motivations for doing it. Let's talk about some different types. So validation testing is the most common. That's what I call it anyway. Some people just call it load testing to keep it general. But I like to break it down and call it validation load testing, because you're validating requirements, basically. You're finding out if the application can scale to meet the expected real-world load while still maintaining acceptable response times. So if you know that you're going to have to be able to support, I don't know, let's say your whole user community is 50,000 users, and as many as 5,000 might be interacting with your application all at the same time, then you know right there you're going to need to be able to support 5,000 concurrent users while still delivering good response times. So load testing could help you validate that. It also would help you to predict if you're going to be able to handle high traffic events. So I don't know, let's say you're going to do a big Super Bowl ad or some marketing promotion. You want to estimate load ahead of time and then plan for that. Also, you can use it for exploratory or tuning work. Like what I mentioned before, if you want to find out the impact of a code or configuration change, or to zero in on the optimal configuration for your app, so like for tuning and stuff. There's also stress testing, which I think we hear a lot about that one. What it really means is, how does the application behave under intense load? So if you push your application to the limit, if you increase the load to the point where you're getting really bad response times and things are hanging and it's in bad shape, does it at least handle the errors gracefully, and does it preserve data integrity? I've seen applications where they're fine normally, but then they get under intense load and maybe they weren't very well written and they weren't using database transactions properly. So you'll get these situations where like one table will get a row inserted, but a corresponding row in another table doesn't get inserted. And so now you've got broken data integrity because of this heavy load issue. So those can be really hard to recover from sometimes, especially if it happens to a lot of different transactions like that. It's pretty much a big disaster if that happens in production. So stress testing is a really great way to minimize that risk. And then there's also stability testing, which is similar to stress testing, except it's seeing if the application can maintain performance over sustained load. So you might run a stability test for like 24, 48, 72 hours, and you want to see if the performance stays as good throughout that whole time, or if it gradually gets worse, or if it suddenly gets worse. Sometimes you see applications where I think the most common scenario for this is database tables filling up. A lot of the time, a database query works really fast as long as there's only maybe 1,000 or so rows in the table. It's probably doing a table scan. But that same table, if it gets up to maybe 100,000 rows or 1 million rows, all of a sudden the query could get really, really slow. So that's something where you just have to load up the database and see. Also checking if memory is handled properly. I've worked on J2EE applications in the past where they did sort of their own caching implementation, and they were using a hash map, which is just where they put a bunch of objects into memory. And it worked great for the short term. Like, it made their whole application really, really fast. But then after a couple days, the whole thing would just hang and seize up, and they would have to restart the app server. This went on for a while, and it was because they were filling up this hash map and then never really freeing the objects from it, and the garbage collector couldn't do anything about it either. So these are things that you'd want to find out from a stability test, and it'll save you a lot of grief down the road, typically. Did we get any more questions?
Yes, we have another question here, Andy. Just a second. Our application is big, and we don't have time to load to test all the features. Are there any recommendations on selecting which features to include for load testing?
Yeah, well, it just depends on what are the most commonly used features, really. If your application, it might do a lot of different things, but there's probably like a handful of things that are the most common user behaviors. So if you have to just choose a few of those, I would work with, whoever understands user behavior the best. Like, I guess it's probably a product management function. So work with somebody who knows the user behavior best and just select what are the top use cases. And then also, it's helpful if you can look at like application logs or server logs or something. You can often get a really good idea of which parts people are using the most, and then just try to represent as many of those behaviors as possible when you create your load test. Yeah, just try to cover most of them.
Okay, thanks. We don't have any other questions yet.
Okay, so where it fits into the application lifecycle, I borrowed this graphic from Polarian.com. I think I like it. It kind of shows all the different parts of the application lifecycle, but it doesn't impose any kind of like a specific process. So whether you're an agile shop, or maybe you're using more like a traditional waterfall, or maybe I know some of you guys might have regulatory processes as well. It doesn't really matter because we're just looking at like the application lifecycle at this point. So as far as fitting in load testing, it's important to determine your performance requirements really early on, like the same time you're creating your business requirements and coming up with functional requirements for the project. It makes sense to also determine what are the performance requirements, and then just document them right there in the same place. So performance requirements could be like, has to be able to handle a sustained load of 500 concurrent users while delivering less than 2 seconds average response time. However it is you want to state those, whatever's important to your user base and whatever is realistic for what's going to be in production, that's what you want to plan for. And then I just recommend documenting those as requirements from the early stages, just like all your other requirements. Also, the next thing, I guess, later on in the planning stage, probably while you're doing design, would be to model your typical user behavior. So like we were just saying, find out what are the most common use cases, the most common behaviors in the system, and then say, well, this is what's in scope for load testing. and it's going to be 60%. Okay, so let's say I'm doing an e-commerce store, just to make it simple, right? We might say, well, 60% of the people are just browsing, they're just looking at stuff. 30% might be looking at stuff and actually putting it in their cart and buying it. And then the other 10%, maybe they're doing stuff like getting customer service or refunds or something. So you just want to have a good idea of that going into it. And then as soon as the application begins to take shape and begins to maybe be on a development or a test server of some kind, you can start creating your test scripts. So that'll depend on what tool you're using. Most of the load testing tools will let you record a script. So you'll pop open a browser, go through all your normal steps. It'll record a script as you go through it, and then you can just tweak that script. So that's something that can be done even before you get a load testing environment. You can create those scripts on like a functional test environment or a dev environment or something. And then the next thing is you want to run the validation, stress, and stability tests. As soon as you get a dev environment and as soon as the app is functional, a load test environment, and the app is functional, that's when you would want to do this. And then last of all, as you're getting ready for production, you can do final tuning and optimization and just make sure everything is tuned properly. Moral of the story, if there's one thing that I could try to reiterate, is just don't wait till the last minute, because these problems can sometimes, if you do have problems, then they can often be some of the hardest to fix. But just because they often have wide-reaching architectural impacts, it could be due to like a synchronization issue in your code, or it could be you need to add a caching layer or whatever it is. Those can make a big impact. So you don't want to find that out in the last few days before going to production. Also, just because running load tests takes time. Like I said, it can take anywhere from an hour to several days to run a load test, depending on if it's just a short-term load test or a stability test. So obviously you want to get a head start. And then if there are issues, again, they require specialized knowledge, so you don't want to be competing for the right person's attention like in the final days before going to production. That's a big mistake, actually, that a lot of people make, is just they do load testing, which is great, but they do it too late in their process or too late in their cycle. So just to recap then, planning. During the planning phase, you want to determine your requirements. The design phase, you can model the realistic user behaviors just to know what you're going to test for. As your app is being implemented, you create your test scripts and scenarios, and then you can actually run the load tests when it's ready. And then you can do continual load tests to tune and stuff even later than that. Any more questions?
We actually do have a question from the previous topic. It's about validated testing. So for validation testing, what are some more examples of performance and scalability requirements?
Okay, so a lot of the time you state them like I did, which is to say the maximum number of concurrent users. And concurrent users is a little bit of it can sometimes seem a little bit vague because it represents a real person doing whatever it is they do. So if there are 500 concurrent users, for example, that means 500 real people who are doing stuff, So a lot of the time you would state them in terms of 500 concurrent users and 90% of the responses have to complete in 2 seconds or less. That's how I usually prefer to do it. Some people actually prefer to take the other angle and give it in terms of throughput. So you could say, well, we have to be able to process 1,000 registrations per hour or something like that. And you can take that and backtrack and extrapolate to state it another way. But that's another way you could state it, is in terms of throughput. I see that quite a bit too. So 1,000 transactions per hour, or 20,000 per day, or sometimes you even have stuff like around bytes per minute or bytes per second throughput too. So it just kind of depends. I like to relate it to real users though, so it's more like what real users are doing with their behavior, at least for customer-facing applications where there's a real user.
That's all we have for now, Andy. Thank you.
Okay. So, we can do a little live demo here, and I'll just show as quickly as possible on a small little sample app. I'll show some of what's involved with Loadster, because obviously that's the load testing tool that I know best. There's other good ones out there too, though, certainly. But so we'll show like script creation, and then building a really basic scenario and running a quick load test, and then taking the report. And then after that, we'll go into what's coming up with the Polari and QA integration. So let me just exit out of the slideshow here. Hopefully you guys can still see what's happening on my desktop. I just fired up Loadster, and it's a little bit pixelated because of the WebEx, but but you can see what's going on at least. So with Loadster here, it's we try to keep it a really simple user interface. Over here on the left is the repository view where it lists all your projects. I've got these 3 projects already that I've been working on. I'm going to go ahead and create a new one for the demo today. And we've got a little pet store app that does a lot of things and we use for testing sometimes. It's called Dangerous Pets. So we'll just do that one to keep it simple. So if I right-click on my project, I can create these different artifacts in here. So I could do a new scenario, a new script, or a new data set in the project. So just to cover what those are really quick, scenario is like, that's a test scenario that includes multiple users. So that's like for a load test. So you might build a scenario where you have 100 users who are browsing for pets, and another 50 users who are actually buying something, and another 20 users who are, I don't know, doing something else, customer service. So that's what a scenario would be. It's a combination of scripts with multiple users. And then a new script, that'll create a script that we can record user behavior and then play it back. And a data set is for parameterizing unique users. I'll show you all of those in a minute. But to get started, let's just do a new script. Call it shopping. Okay, so here's our script. You can create commands in the script a couple different ways. You can manually add them with add script command, where you can enter all of the parameters for the HTTP GET or POST or whatever your verb is. To be honest, that gets a little bit tedious. So I usually prefer to record one to begin with a browser. So I'll click record here. Loadster gives us the option to launch a browser. I'll go with Firefox. You can also clear cache and cookies at launch if you want to be extra safe to make sure that your browser doesn't have certain resources cached, which would cause them not to get recorded. Cookies are not usually such a big deal because it's launching a fresh browser anyway. But I'll launch a Firefox here. Okay, so here's Firefox. Loadster says recording's in progress. So I'll go to the petstore.loadstoperformance.com. Now, hopefully you'll excuse the silliness of this little pet store here. It's just for testing out Loadster, so it's a little bit goofy. But I like testing on it because it does a lot of real-world stuff. I mean, it's got session management to keep track of your shopping cart. It's got big web forms with posts in them. You have to deal with cookies and everything. So it's really a kind of a good way to showcase very briefly some of the tricky parts of scripting. We got this little message from Loadster, HTTPS errors detected. I'm not going to worry about that because those are just Firefox phoning home, and we don't need to record that traffic for our load test anyway. This load test is all HTTP. So let's go ahead and browse a little bit. I'm the user now, so you see as I browse, Loadster's recording my steps over here as HTTP gets. We can pick out one of these fine animals here. Going to give me a honey badger. So we just added the honey badger to our cart. We can see in the Magento store here that it's there, and we also see some more requests that were us adding it to the cart. So it's in our cart now. I'm going to proceed to checkout. You guys have all done this before, so I'm not going to really belabor what I'm doing here. But I'll just go through and put some stuff in. I'm going to use this fake email address too because we want to keep them unique, and I'll show you how to keep them unique as we play through it again. Okay, so continuing on, yeah, we'll take flat rate shipping. Put in a test credit card here. Okay, so it's confirming our order here. Grand total looks about right. I'm going to place the order. And still Loadster's recording. Looks like it got some posts in here too. That's good. Okay, so we got an order number. We'll receive an order confirmation email. That's good. And so we'll call that a script. That's all we're going to do for right now. So then I stop the recording, and now I see all my commands are right here. If I want to inspect the commands, I can do that. So if I want to look at the mean mammals category page, I can I can do that. I can expand it by double-clicking and look at all of these things. So I could change the method. If I was doing things manually, I could change the location. If I was switching to a different server, I could do a find and replace on my script and change the host name in all these. There's a lot of other features too, which we don't really have time to get into right now, but and you'll find some of these in different load testing software as well. So some of them are fairly universal concept. It's necessary for testing any kind of like modern web application. You can go in and edit the query parameters here on the query string. You can bundle these page resources with it. So you see we've got the main get here for the category page, but we also have all these images and things. You can add validation rules too. We can say, well, make sure when I hit this that it comes back with a certain message. We could add a validation rule that says it can't have a certain message, like an error message. We could set restrictions on the page load time. Say the load time must not exceed 3 seconds. This is a really critical page, so it needs to be really fast. So we consider it a complete failure if it takes more than 3 seconds or whatever. Also the page size. So these validation rules, you can add multiple rules for each command, and it's a good way to sort of keep yourself honest and make sure that you're really putting the application through its paces. And also, it's a good way to tell conclusively if it met your requirements or not. There's also capturing rules, which let you capture a value either from an HTTP response header or from the body itself. If we're lucky, we don't have to use these. But sometimes with dynamic web apps, the server's generating a token that you have to reuse later in your script. One classic example is, let's say you're registering a new account, and then after registration, it gives you an account ID. And then next time you want to go see your account page, you need to include that account ID in the account page. So you'd want to be able to include that there. So that's when you would need to capture it, and you can reuse it as a variable. And there's also custom HTTP headers, which are another kind of advanced feature. So anyway, enough about that. Let's play through our script once to see if it recorded right. I don't want to have to do all these wait times because you guys will get bored. But so I'll do skip wait times during scripting playback. Save that. Okay, and now we're playing it back. So now Loadster is going through these same steps that we just recorded, and it's playing them back to hit the application again. You can see down at the bottom there's our playback log where it shows exactly what's happening. It shows the HTTP response code, 200 OK, that's good. Sometimes it shows, if there were other resources like the images and style sheets, it shows where it's loading those resources as well. So yeah, so far it's all green check marks, so that's good. All right, it played perfectly the first time with no errors. That's good. Sometimes with applications that won't be the case, and that's when you have to go in and do some of the special capturing rules to parameterize your variables and stuff. There's documentation on, if you're interested, there's documentation on LoadstoPerformance.com that shows how to do that. So one other thing I'm going to do, I'm going to go through and fix these wait times so that when we play our load test, it plays with the correct wait times. So normally, these are actually really important. It looks like a minor detail, but they're actually very important because you want them to be realistic. Because if your real users are going through and filling out these forms and stuff, it's going to take them a certain amount of time on each one, and that'll affect like your scalability numbers and everything. So you want to have realistic wait times. I'm going to compress them a little bit because we're in a hurry today, and I'm just demoing anyway. So we'll compress them a little bit so that we can run a quick load test. But normally we want to give it some thoughtful consideration on what these should actually be. Now I should also mention you can reorder commands, you can drag them, you can delete commands and stuff like that, but we won't get into that. What I do want to show though really quick is how we can use a variable. So we'll go into save billing and we'll look at the request body. So yeah, in the request body, we want to be able to edit as parameters. We can go in and see this is what was actually sent with the form when we submitted the form. So these are all of the different parameters that were in the post body, and then these are the values that we sent. And if you're paying attention, you'll see these are the actual values that we filled out. So I'm going to go ahead and replace this. I don't want to be sending the same email every time, right, and the same username and stuff, because that's not very realistic. So I'm going to go ahead and parameterize these into a variable. So we can use, if you've done programming, then it's kind of a common notation. The variables treated as there's this escape sequence, and then there's like this array index. What we're doing is we're having a variable that we're going to use called user, and it's got 3 entries in it. It's got a first name, last name, and an email. And we're going to substitute those when we play through the script. So I've tweaked it here. That's good. Go ahead and save. But now you're probably wondering, where does user come from, right? So that's a good question. Right now it doesn't come from anywhere. Let's create a data set where the users will be stored. So we'll call it users. It doesn't have to be called the same thing. And we need to add 3 entries, 0, 1, and 2. So I'll put myself in there, and we'll do Andy 101. All right, and then let's just make a couple of them. I'll make 2 more. You can also paste these in from Excel or from some other thing if that's a little less tedious doing that. Usually it's good to have a pretty big data set, and then you don't have to worry about collisions of reusing the same data in the test, because depending on how the app validates it, it might not let you re-enter the same email address for a subsequent purchase or something for a registration. Okay, so I created the data set now called users. I'm going to go back in my script, and I'll go ahead and configure data set variables. So here's where I create the variable that's going to use the value from my data set. I'm going to call it user because that's what I called my variable. And we don't really care about these update and selection strategies right now for the demo, but this would be telling it how to pull things from the data set, if it should pull a new one every time, or if it can reuse the same one, if it should pull them at random or sequentially. We'll just do it one for every virtual user and then sequentially. Okay, so there's our script. I guess let's double check one thing, and then we can play it one more time just to make sure that we're doing the right variable thing. That is parameters. Okay, user 0, user 1, user 2. I think it looks right. So I'll go ahead and play it one more time. Reg, are there any questions so far? Sorry, I've been sort of monologuing.
No, we don't have any interesting enough anymore at this point. I think everybody's just looking at the demo.
All right. All right, cool. So no errors. So now I want to make sure that my variable was actually used. So here in the script editor, we also have this little results tab where you can drill down and look at what actually happened when you played through it. So we've played through it twice so far, at 9:07 and 9:12 a.m. here. So I'm going to look at the 9:12 one. That was just now. I'm going to look at save billing, which is the post where we posted all my billing info, credit card and email and everything. So we look at the request. You can look at the request headers or body. If you look at headers, these are all the actual HTTP headers that were sent. So it gives you a really low-level way to look at what was sent to the application. We can also look at the body, where it opens up here. Now the body here is URL encoded key-value pairs, which is typical for most HTTP form posts. But yeah, okay, first name Andy, last name Hawks, and then let's see, where's the email? Andy 101, yeah, so that was pulled from the data set. And if we ran it again from the data set and we were randomizing, it would pull a different random one. But that's good enough for me for this short demo. So it looks like our script is working. It looks like it's using these dynamic variables values from the data set. So let's go ahead and build it into a little test scenario, and we'll run a small load test. So we'll do a new scenario. We can call it whatever we want. We can call it weekend shopping day. All right, so go ahead and add a population. So this will be a group of virtual users, as we call them, who are actually executing the script. So we've got our script called shopping, which is the one we just created. We can give this population whatever name we want. We can say shoppers. And this pet store is running on a really small Amazon EC2 instance. It's pretty lame, so it doesn't really support very much load at all. And I haven't done any tuning or anything either. So we're just going to run a really small load test here, see how it does. 5 users. It's got ramp up and then peak load, and then ramp down. The ramp up here is where it ramps up. You can also do different strategies for ramp up. So let's say I just ran a commercial and I want to see how it goes after the commercial. I would use an aggressive ramp up here because everybody's going to start hitting it at the same time, so it'll ramp up more aggressively. It's not very meaningful if you're just doing 5 users, but if you were doing like hundreds of users or thousands of users, it's very meaningful because a lot of the time if you just slam the application all at once, it hurts it a lot worse than if you do a nice gradual stair-stepping ramp-up. So I think aggressive is a good way to simulate those sorts of situations. Likewise, there's ramp down. You can do a delayed ramp down, which will be like this. You can do a linear ramp down, which is a straight. Natural is just fine. It doesn't matter for this test, honestly. You can also distribute the load to a different load engine. So for 5 users, of course, it doesn't matter, but if I was running a big test and it was more than my workstation could generate load for, then I could install the Loadster engine on another PC somewhere or wherever I want, and I could farm out the load generation to that. So that's a good way to do distributed load tests. It's also a good way, like if I'm sitting here at my house, I don't really have like unlimited network throughput between my house and Amazon's data center. So it might make more sense if I was running a big serious load test. I could deploy my load engine on an Amazon box at the Amazon data center, and I could still control it from my house. So that's pretty useful if you want to be realistic like that. I don't want to saturate my cable internet line doing serious load testing. But we're just going to go built-in for now. That's fine. And there's also, if you're interested, there's these advanced playback options. So you can simulate the connection speed. So you can see, you can make a population of like broadband users who have, 5 megabit broadband. And that's a little slow nowadays. I should update these. But yeah, so 5 megabit broadband, or you could do like an Ethernet connection or whatever to simulate the impacts of a slower connection. You can also tweak things like the resource timeout, the number of threads per user, because browsers use multiple threads when they download all their images and style sheets and stuff. So Loadster does it the same way, so it's realistic. And then we could also even randomize or constrain the wait times as well. But yeah, we don't need to do that for this test. So let's just do OK. There's our scenario. We could add more populations too if we wanted to, and then they would be stacked on top of this one. It would give us like the, sort of a preview of what it's going to be doing. But let's just go ahead and play it here. So we only have like 12 more minutes actually. So this is going to play for 3 or 4 minutes. I made it about as quick a load test as I could just to show you guys. But you can see it's starting to gather data points already. It's up to 3 virtual users already because we did the aggressive ramp up. And you can see for each page that it's hitting, it's showing us this live graph that shows like what are the average response times it's seeing. They're not too good already, even with just 4 users. But yeah, it's just a pet store after all. But so we can keep an eye on our test right now. This would also be a great time to be watching what's going on the server simultaneously. I'm not doing that just because it's a short demo. You can also look at the aggregate numbers over on the left here. So we've got like total throughput numbers in bytes, pages, and hits. So this is how many bytes, pages, and hits we've transferred so far. Also current throughput, which updates every second or so, which shows what it's doing right now. So you see sometimes there's like temporary lulls while every user is waiting. Sometimes, if all 5 users have a wait time at the same time, it'll go to 0. Which is less of an issue for bigger tests, obviously, because then it's more spread out. Also, it shows the status on each of our load engines. With only 5 users, our load engines are not working hard at all. And actually, this other one called Homer is totally idle. There we just had an awful response time here, the spike here on the checkout, the one-page checkout. So all right, it's just another minute or 2 of this, and then we can export the report. Anybody have any questions or comments or, different experiences you'd like to share or anything?
No, we can continue.
Okay, all right. Well, let me show you some of the other graphs, too, that you can look at in real time. So there's average response times per page, which we looked at. That one's pretty useful. There's also, you can look at the running virtual users, and it's following more or less that same pattern that we created at the beginning, where it did the aggressive ramp up, and now it's starting to ramp down. We're down to 4, and it looks like now we're down to 3. So it's finishing up now. We haven't had any errors yet, which is good, but otherwise it would show us a graph of like errors by type and also errors by page, which page they happened on. You can also view in a tabular format like the error breakdown. So that would show us what type of errors they were, what was the error message, which group and which user it happened on. So the group is basically which population had the error. We can also keep an eye on throughput. So looks like for this small load test, we haven't even gotten above 2 pages per second, that's tiny. Hits per second is different than pages per second because it includes all those things like the CSS and the JavaScript and stuff. And bytes per second here, that's just the total upload and download bytes taken together. So, okay, we're down to 2 users. And we set it up for a 3-minute test, but sometimes they need to finish their current iteration before they exit. So it's actually going a little over 3 minutes as the last users finish up their scripts. Okay, there we go. It's just about to finish now. Okay, test is finished. So, all right, so then we see the test results now saved under our scenario here, so you can always go back and reference it any time. We can also enter our own summary or notes before we generate the test report. So we can just say 5 virtual users buying honey badgers. And then notes. If I were more thoughtful, I could type in some good notes here for the report that I can send all my friends, but we'll just do it the easy way right here. So, okay, so we've exported the HTML report. I put it on my desktop here. So here it is. It's got the HTML page, and then it's got all the images and everything built in. So you can see the little summary and notes I added, and then also an overview of the test. So we've got the test, tells what scenario, when it was started, how long it ran for. This is just a recap of like the whole configuration that we were using. We've got the ramp up, peak duration, ramp down, so you can always look back and tell what happened. There's also a breakdown of the test results, how long it ran for, how many pages, how many total bytes, how many bytes per second. Everything that we could see in real time, we can now see on the report too. Also, this is really good, the 3.3, the response times. This shows what are our worst offending pages. So, interestingly enough, this one had a 10-second average, but the max was 41 seconds. So, there must have been some concurrency issues or some kind of bottleneck that was hit, obviously. And so this one accounted for a total of 73 seconds wait time throughout the test. So, if I was looking to optimize this application, I would probably, I'd start with general stuff first, system-level stuff, but after that, I would probably look at this top page here because it's the worst offender for response times. So it gives me a good idea where I need to focus my efforts. There were no errors detected, but if there were, they'd be right there. That was our planned scenario. There's our average response times per page again. You can hover these to see the whole URL as well. So yeah, and then it's got all the other graphs too, which are about the same as the ones I showed you during real time. So yeah, that's kind of it for the Loadster report. There's other features too that I didn't show because we're already running out of time. But so I guess we can go back to the PowerPoint if there's no questions, and then we'll just continue. Okay, so talking about next steps then, this is our upcoming integration, which I'm really excited about. It's already a work in progress, and it's coming together here. Reg, did you want to share about what's involved here?
Sure, Andy. Okay, so what I wanted to do is just discuss the fact that this is actually currently in the works. It's a first for Polarian, where we will have a bidirectional workflow with a performance and load testing software. In particular, it will be Loadster. It will be available shortly. What we'll do today is we'll tell you how it works, and we'll show you some of the actual screenshots. And if you want to, feel free afterwards. This will be a recorded event that's available on both our websites. But if you want, you can sign up through our website or even your sales reps if you want to get access to the early adoption of this integration. And Andy, did you want to just continue through the how it works?
Yeah, sure. So basically, like the big benefit for this first phase of our integration is the ability to export your reports from Loadster into Polarian QA. So, I mean, many of you are already using Polarian, obviously. So it gives you the benefit that you already enjoy with your other test results, where you can have them all in one place. So your regression testing, your manual testing, your automated unit testing, if you're doing that, as well as now your load test results will all be in Polarian QA. What's more, you'll be able to specify your pass-fail criteria. Remember the load test validation or acceptance criteria we talked about earlier? So you'll be able to specify that in Loadster before running a test. And then when your test is done and you export it into Polarian, it'll automatically create work items for any failed load test. So basically, here's the steps. So number one, you configure your acceptance criteria, and then here's some more examples of what those might be. I know we had a question earlier about some examples. So it could be stuff like this, and you can specify about as many as you want for each load test. Then the next thing, you would just run the load test in Loadster, and then from your test report editor, instead of exporting the HTML report, you'll be able to share and then select Polarian as the destination. It'll automatically upload it into Polarian QA for you, so it's all in one place.
What's very important about that, to reiterate what Andy's talking about, is currently in a lot of load testing, performance testing software, results get shared across a distributed environment. It's a crude fashion, and typically it's by email. So what this will allow us to do is you'll actually have a centralized platform where you can manage those results. So not only you'll see the results, but you'll be able to manage those effectively through Polarian QA.
Yeah, definitely. Like it'll go in here just as a test run, just like all the other ones. Here's a preview of what it looks like. So it's even imported like the Loadster report that we generated. Although this one here is a mock-up. It's not the very same report that we just generated. But so it's imported like the summary, the additional notes. If you look over on the right, we see the outline of all the contents of the Loadster report. But maybe most importantly, like Reg was saying, front and center, it's got like the passed and failed out of all the different criteria. So it looks like for this one, 3 of them passed and 5 of them failed. So you can drill down into that. It's all in one place. You don't have to email it and all that stuff. So what's more, the issues are automatically created, so people can start working on them. Here it's showing, like, for those that failed, it automatically created defects in Polarian. So you got work item 4, work item 6, and so on. So, I mean, that way you can assign it to a developer or a systems expert or whoever is the best suited to figure out why that load test failed on that particular criterion. And then they can work it just like they would any other defect in Polarian. And as they're doing that, they can always revisit the test results without leaving Polarian QA. They can you know, they're investigating why something went wrong and they need more details. They just look at the load test run and then scroll down and see everything there. So yeah, we're pretty excited about it. It's I think it's going to be a cool thing and pretty useful. So like Reg was saying, it's still a work in progress. We're going to have a formal announcement soon when the integration's complete. And if you want to try out like an early version of it, we're interested in finding people who would like to try that out. So you could email Reg or you could email me. I'm Andy at LoadstoPerformance.com, or you can just send it straight to info@LoadstoPerformance.com if you're at all interested, or even if you just have like general questions or something. We also have a mailing list at Loadster, which is, you can join that at this URL here if you're interested in joining that, and then we'll issue an announcement when this is ready. Mailing list also has other stuff like load testing tips and also front-end and back-end performance tuning tips and other stuff like that. And we try not to send too many emails either because we all get so many. But it's usually pretty good stuff. And then here's our Twitter and everything. So, yeah, I mean, feel free to reach out to me if there's anything you need, even if you just want to bounce ideas off or something. I always like to talk. So even if you're not interested in Loadster per se, that's fine. So Reg, did you have anything else to add?
I know. What we should do is go very quickly. Time's running out, so we're over time by a couple minutes. If we can go through the FAQ, and then we'll just wrap this up fairly quickly.
Okay, sure. Yeah, we have a couple of FAQ slides after this, and this is just things that I thought of that I run into all the time. So, okay, so I don't have a production-like environment due to budget or time constraints. When is it safe to run load tests in a different environment and extrapolate? Actually, this is really similar to one of the questions from earlier, so about if you can use a smaller environment. So the general thing that I would say to be aware of is it's okay to extrapolate and treat it as a worst-case scenario, typically. So if you have a smaller environment, you can almost always say, well, it'll run at least this well when it gets to the bigger production environment. There's a few exceptions to that, but usually that's a safe assumption. And also you can do testing just with the goal of discovering ways to improve. So finding what is the bottleneck, finding possible concurrency issues in the code, cases of poor memory management, that kind of thing. So those are still useful tests, even if you don't have an exact one-to-one replica of your production environment. And then another FAQ, so what other tools are there besides Loadster that can generate the load? There's a bunch of them out there. There's some other good commercial tools. Some of them are quite expensive, but they tend to offer a really good combination of features and flexibility as compared to the cloud-based or open-source tools. So if you have an application that does a lot of stuff, a lot of session management, maybe some Ajax and stuff like that, cookies, then you need something, either Loadster or one of the other higher-end tools, or JMeter is great. It does a good job. It's totally open source. The one thing is that you kind of have to have the time to ramp up. It takes a long time to learn, and it's I feel like it takes longer going forward, but other people have different opinions about that. But if you don't want to get a commercial tool, I think JMeter is a good choice. And there's a few others like OpenSTA and Grinder that you could check out. And then also there's, in the last couple of years, there's been all these cloud-based solutions, which are completely cloud-based. Those are good if your needs are fairly simple. They're ideal if you're testing like a static website or a mostly static website, because it's a really good and cheap way to generate a whole bunch of traffic against your website. Where it can get challenging with the cloud-based tools is the scripting, though. If you have like a more, like a more featured web application, then it can be more challenging to create scripts that actually work with it from the cloud. And then the other thing is, if your test environment's not publicly available on the internet, then the cloud-based solutions are no use to you. So, okay, yeah, so that was our last FAQ. I guess we're out of time, but if there's any other questions, feel free to get in touch, or here's some resources here. This is our website.
Andy, thank you very much for today's very insightful presentation. Everybody, we will make this available for you actually on our on-demand webinars on our website, and feel free to contact either Loadster or Polarian Software should you want to learn about the products or the integration that we talked about today. Thank you very much, and enjoy the rest of your day.
Thanks, everyone.